Hello, this video is on functions. Specifically, it's the second of two videos on cubic models, as shown here in the syllabus. A mathematical model is a simplified description of a real-world system using mathematical concepts. The process of developing a model is called modeling. For example, the shape of part of a roller coaster ride can be modeled by a cubic function. A cubic model has the general form shown here, where a, b, c, and d are constants, called the coefficients. Cubic models are frequently used to describe situations where one quantity, the dependent variable, has an inflection point relative to another quantity, the independent variable. To find the equation of a cubic model, one of two methods can be applied. Either method 1, using a system of equations. We will solve simultaneous equations with 4 unknowns. Or method 2, using cubic regression, where we will find the equation of the regression curve. In this example, to find the equation of a cubic model by using a system of equations, we need to first identify 4 points on the curve. Substituting the coordinates of the 4 points into the function gives 4 equations involving a, b, c, and d, as shown, which can then be simplified. To solve this system or set of equations, from the main menu, select Equation. Press F1 for simultaneous, and then F3 for 4 unknowns. And then enter the coefficients of the 4 equations. So for the first equation, that's 0, 0, 0, 1, 49. The second equation, 1, 1, 1, 1, and 44. For the third equation, 8, 4, 2, 1, and 57. And for the fourth equation, 27, 9, 3, 1, and 50. Pressing F1 to solve the system gives the values of a, b, c, and d as shown. Rounding the values to 3 significant figures gives the cubic model shown. To find the equation of the cubic model using cubic regression, you still need to identify 4 points on the curve, but this time we will enter them into lists on the calculator. From the main menu, selecting Statistics and entering the x-coordinates into list 1 and the y-coordinates into list 2. So starting with a 0, and then 1, 2, and 3, the values of the x-coordinates, list 1, and for list 2, 49, 44, 57, and 50. Pressing F2 for a calculation, F3 for regression, F4 for cubic regression, giving the values of a, b, c, and d as shown. Rounding the values correct to 3 significant figures gives the same cubic model as before. In this question, we're asked to find the values of a, b, c, and d in the cubic model. Starting by identifying 4 points on the bike track. And as I'm going to use cubic regression from the main menu, I'll select Statistics and enter the coordinates. Entering the x-coordinates into list 1, so that's 0, 5, 10, and 15 in list 1, and then the y-coordinates into list 2. That's 5.209, 7.264, 5.719, and 2.824. Pressing F2 for a calculation, F3 for regression, and F4 for cubic regression. Give the values of A, B, C and D as shown. Substituting the values of A, B, C and D correct to 3 significant figures into the function gives the cubic model shown. In part B, to find the height of the bike track at point E, substituting in the value x equals 20 into the model as shown and performing the calculation gives the value shown. So the height of the bike track at point E is 0.829 meters, correct to 3 significant figures. In this question, we're asked to write down 4 equations that can represent the model. If we begin by writing down the function and then substituting the values into the function. At the start of the festival, that's when t is equal to 0, there were 20,000 people there. At 4 p.m, that's when t is equal to 4, the number had risen to 25,368. At 8 p.m, that's when t is equal to 8, the number had dropped to 7,824. And at 10 p.m, that's when t is equal to 10, the festival had closed, so there was nobody there. Simplifying the equations gives the system shown here. To enter the system, from the main menu, select the equation. Press F1 for simultaneous and F3 for 4 unknowns. Enter in the coefficients of the equations as shown. Pressing F1 to solve the system and substituting the values back into the equation to give the model connecting n and t. In part C, we're asked to predict the maximum number of people at the festival and the time when this occurred. So if we draw the graph of the function from the main menu, selecting graph, and type in the equation into y1. So that's 79.5, then pressing the x variable button and the power button, 3 to get x cubed, and the right cursor to come down, subtracting 1670, pressing the x variable button again, and the squared button, and then plus 6750, pressing the x variable button, and finally add in 20,000. Pressing execute to enter the equation. Pressing Shift F3 to access view window and set in the values as shown. Pressing execute and then pressing F6 to draw the graph. To find the maximum point, press F5 for G-solve and F2 for maximum, given the values shown. Converting the value of t, the time, and adding it on to 12 p.m. by multiplying by 60. So the maximum number of people at the festival was 27,700, and this occurred at 2:27 p.m, both correct to 3 significant figures.